Hey CPD scholars, I hope you're all well and safe, washing your hands, doing all the things you can to grow your brains. We all miss you in 5th grade. We can't wait to see you during graduation and all the other things that are coming up. Today's lesson, we are doing our second lesson in our space topic. We're going to talk about the outer planets, so here we go. Log on to Nearpod. The code for this week's lesson is YFOPT. Again, YFOPT. Hit join. Still loading. Put in your name, your homeroom. Alright, so the outer planets. This quote down here, we are not simply in the universe, we are part of it, we are born from it. It's real deep. Think about it. Our essential question for today is, what similar characteristics do the outer planets of our solar system share? So by the end of today, you should be able to answer this question. What similar characteristics do all the outer planets have in common? Remember, characteristics are what makes something something. So your characteristics might be you have black hair, you might have brown eyes, you might be tall, you might be short. Characteristics just describe something. Our objective for today, you're going to be able to explain the unique characteristics of the outer planets in our solar system and identify specific facts about these planets. So you'll be able to tell me what do all the outer planets have in common, as well as name some interesting facts about the outer planets. Here we go. Starting off with an open-ended question. In your own words, what is a solar system? What is a solar system? How would you define it? This is our solar system with the sun in the middle. You got the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. We got some comets. What is a solar system? I would define it as a solar system is, what do all these things have in common? Again, the planets, the comets, the asteroids. Oh yeah, they're all orbiting around the sun, right? So a solar system is all the material that orbits around a star. I think that's a pretty good definition of a solar system. You might think of something else. Write it down. So what is a solar system? A solar system is all the planets, asteroids, meteors, and other space material that orbit around the same star. You might think that only our solar system is the only solar system in space. That's not true. Each star has their own solar system. You might think of systems like we have at our school, like the system to go to the bathroom, where all have a common thing, a common purpose. So a system is just all the common things sharing one star. So what do we already know about the 4 inner planets, Mercury, Venus, Earth, and Mars? And how do we think the outer planets are going to be different from the inner planets? So let's think. Last week we talked about, or last time, the inner planets are, made out of rocks and metals. We call them terrestrial. They're also all relatively small compared to the other planets. And they don't have very many moons. Only 2 of the planets, Earth and Mars, even have any moons. So the second part, how do you think the outer planets are going to be different from the inner planets? Well, let's explore. On the next 4 slides, you will explore 3D models of the 4 outer planets in our solar system: Jupiter, Saturn, Uranus, and Neptune. These outer planets have similarities that make them different from the inner planets. So all these planets have some stuff that makes them different than the inner planets. See if you can determine what the outer planets have in common. So I just want you to look at the models, see if you can figure out what they have in common. So first up is Jupiter. You can spin it around. If you're on your iPad, you can actually zoom in by pinching. Can't do it on my computer, sadly. I wonder, this almost looks like water. So maybe there's some sort of water on Jupiter. Or maybe it looks like clouds almost, like clouds over the Earth, which is a gas. Huh. After Jupiter, we have Saturn. You can tell Saturn because of its famous rings. These rings are just dust and tiny rocks that got trapped in this planet's gravitational pull. So if you could fly there, you would just see tons of teeny tiny rocks and gas and dust just zooming around. Again, this one's got kind of that lighter color. It's got some lines in it, maybe. I wonder if those are like cracks, maybe in the surface, or if they're like, looks a little bit cloudy again, so maybe it's a gas. Huh. Next is Uranus. A lot of people don't remember this, but Uranus actually has some rings. They're not as big or bright as Saturn's, but these are still rocks and dust that got trapped in this big planet's orbital field. As you can see, this is a blue planet, but that doesn't really look like water to me. It looks kind of cloudy, almost like a snow cone or something like that. Huh. And the last one, Neptune. This one's kind of got that same cloudy look as Jupiter. Again, it's blue. It's got rings. Lots of clouds, dust. Rotate it. Turn ups on the poles. I don't really see any land features on any of these planets. I don't see any mountains or volcanoes. I see clouds, but I don't see any land. Interesting. You're welcome to explore more. What did you observe? What were the similarities and differences between the outer planets? Which planets were the biggest and the smallest? What did you notice about their core and atmospheres? So these are some of the things you should be thinking about. Maybe if you have somebody to tell what you observed to, like maybe a brother or sister. A second grade teacher gave me a good idea that you could talk to your dog or even a stuffed animal. I know that seems silly, but remember we said the only way to remember stuff is to think about it. So if you talk about it, you're thinking about it. That's what I would recommend, but it's up to you. So what characteristics did you think the outer planets have in common? So here's some places to write your thoughts down. This is just an idea chart. There's no right or wrong answer. So if you have some paper, you might want to write it down there if you're not going to do the lesson on Nearpod, or you can put them here. I'll get us started. Most of the outer planets had rings. I saw 3 out of the 4 outer planets had rings around them. So maybe that's a characteristic that they have in common. Maybe Jupiter's rings are just so small we can't see them. What other things did you notice? So write them down. You can either put them here or on a piece of paper. So let's explain what we observed. So the outer planets, on the next slide, you're going to read the text that explains the characteristics of the outer planets in our solar system. Focus on what the outer planets are made of and how large they are. So while you're reading, you got a purpose. Read for information about how big the planets are and what they're made out of. Your website should pop up like this. The outer planets are Jupiter, Saturn, Uranus, and Neptune. They are also sometimes known as the gas giants, as they are all huge in comparison to the inner planets and made up mostly of gas, so don't have solid surfaces. Those are two hints or key details to our question already. They're gas giants because they're made out of gas, and they're giant compared to the inner planets. Interesting. The first of the outer planets is Jupiter. It is also the largest of the outer planets, and it is so big that Earth could fit into it more than 1,400 times. So that's, our brains probably can't even picture anything that big. Well, they can't because we've never seen anything like that. Jupiter is 1,400 times the size of the Earth. It is the largest planet in our solar system. Jupiter is a massive 500 million miles away from Mars. So the space between Mars and the next planet Jupiter, 500 million miles. Again, our brains can't even picture that because it's so huge. Neptune is the smallest and most distant, but is still big enough to contain 60 Earths. So even Neptune, who's so far from the sun, is still 60 times bigger than Earth. Like the inner planets, the outer planets share similarities, but each also has its own unique characteristics. So they all have some things that are the same, but they're also a little bit different. As well as being huge and being made up mostly of gas, what are they made out of? All four have rings spinning around them, with Saturn having the most famous rings. So they all have rings. I wonder why. All four planets also have large numbers of moons orbiting them. We know why, actually. Remember we talked about the inner planets are small, so they don't have as much gravity. Well, the outer planets, the gas giants, are huge, so they've got tons of gravity. So they keep on sucking in all these rocks and other satellites coming around in their areas. The picture below shows the orbit of the outer planets, including Pluto, which is a dwarf planet, which crosses the orbit of Neptune, and was once classified as an outer planet. It also shows how close the inner planets are to each other, appearing as balls in the middle of the picture. Even though there are millions of kilometers away from each other, it also shows the orbits of three comets: Halley's Comet, Comet Chromalion, and in red, Comet Hyakutake. So this is their orbit. You can see the inner planets are pretty close to the sun, but these outer planets are much, much farther away, and their orbits are even farther, so they're even farther away from each other. So there's a lot more space between the outer planets than the inner planets. You can see Pluto, the dwarf planet, and what's interesting about Pluto and why we say it's not a planet anymore is because when it orbits, it actually comes inside of Neptune's orbit. So they're not so sometimes Pluto is actually closer to the sun than Neptune. Interesting. Remember, we said that for something to be a planet, it has to have a clear orbit. So since it didn't have a clear orbit, it went inside someone else's orbit, it's not a planet. It's a dwarf planet. You can also see some comets. We talked about comets. They're just huge balls of frozen ice and gas that are orbiting around the sun. And when they get closer to the sun, they start to burn up, leave a tail. They've got kind of interesting, almost like squished orbits. So despite these similarities, each planet has its own characteristics. So let's look at them. Jupiter is the biggest planet in the solar system. A day on Jupiter takes 9 hours and 55 minutes, meaning that planet spins very fast. So Earth takes 24 hours for a day. Jupiter takes 9 hours and 55 minutes, so less than half the time, so it's spinning much faster. It takes the Jupiter 11.9 Earth years to go around the sun. That's because it's so far away from the sun. So its orbit is so big, it takes 11.9 Earth years for it to go one time around the sun. Jupiter, skipping down here, is mostly known for this huge red spot right here, which is actually a huge storm. This storm has been going for years. That means that scientists have been seeing the storm, and it doesn't go our storms, they usually are over in a day, maybe 2 days. This storm has been going on for years. This planet has 79 moons, which is including Ganymede, which is the largest moon in our solar system. is actually bigger than Mercury and Pluto. The moon is. Lots of moons, made out of gas, interesting red storm on it, and the largest planet. That's what we gotta know about Jupiter. Saturn is made up of hydrogen and helium, which are gases. It is so full of gas that its density, or the amount of matter in an area, is so low that if there was a sea of water big enough, it would float on it. So it's huge, but the gas is so unpacked or not dense that it would actually float in water. Interesting. Saturn takes 10 hours and 39 minutes for a day. So again, half as fast as Earth's day. So it's spinning very quickly. And it takes 29 years, Earth years, to go around the sun. Saturn, has lots of satellites, like dust and rocks that are orbiting around it. That's why we say it's got these beautiful rings. Some of these, they say, are probably a shattered moon, which once orbited Saturn. So remember we talked about sometimes there's big collisions in Earth and meteors and moons break apart into smaller pieces. So scientists think that happened with Saturn. It's got 62 moons, and most of them are small, except for Titan, which scientists believe could possibly have an atmosphere like Earth's. So we've actually started exploring Titan as a place that if Earth ever was in danger or got too much pollution, that kind of thing, we might be able to move some people to Titan. Hopefully you don't have to do that. Next is Uranus, possibly the most boring planet in the solar system. Well, that's an opinion. Uranus has an atmosphere of hydrogen, helium, and methane. All of those are gases. The methane gives the planet a pale blue color. The planet is tipped on its side, possibly from a collision with an object the size of Earth. So remember, Earth's tilt is 27.5 degrees. Uranus is on its side like this. So it's spinning on its side, probably because something knocked it off its axis. It takes 16 hours and 7 minutes per day, so a little bit slower than half of Earth's day. But it takes 84 years for it to go around the sun one time. It's got 27 moons, including one called Miranda, which is what they think might have knocked it off its axis. Interesting. It does sound kind of boring. I think it's beautiful, though. The last planet is Neptune, often considered to be Uranus's twin. I wonder why. They look very similar. Neptune is a similar size and has similar content in its atmosphere. So it's about the same size, made out of the same kind of gases. It orbits the sun every 165 years. That's incredible. That's a long time to go around the sun. The planet takes 16 hours and 7 minutes to turn on its axis, so still spinning very fast, but it just has to go a long ways around the Earth. The winds on this planet are the strongest in the solar system, with areas of high pressure shown by dark spots. So you see these dark spots on the moon, that's where there's huge wind storms just blowing and blowing and blowing. Clouds of icy droplets of methane can also be seen in the upper atmosphere of Neptune. So it almost has like snow, but not made out of water, made out of methane. This planet has 14 moons, including a moon with eruptions of nitrogen, like a volcano. So I hope through this reading you can see that they're all made out of gas. They're all really big compared to the inner planets. They all have many more moons than the inner planets, and they actually all have rings. So those are 4 similar characteristics. But you could also say they have differences, like they're different sizes, they're made out of different things, different colors, different amount of moons, those kind of things. So I encourage you to explore more on this website if you have time. Lots of cool information about space. But I'm going to minimize it and go back to our lesson. Alright, so your job is to underline or star characteristics of the outer planets. So you're going to read through this list, and you're going to either put an underline or a star next to the things that are true about the outer planets. I'm going to highlight, actually, I know it's not one of the options, but, well, they're not made of rocks, but they are gaseous, which just means they're made out of gas. Are they small or large? Yeah, really large. We already said they're not made of rocks. Have many moons orbiting them? That's very true. One had 72. They have few moons or rings orbiting. No, we just said many. Colder or warmer? We didn't really talk about this, but you could use your intuition. If they're very far from the sun, would they be hot or cold, do you think? Yeah, they'd be colder. They have lower densities. Remember, if they're made out of gas, gas is the least dense state of matter. Yeah, you guys know that. Are they farther from the sun or closer to the sun? Yeah, farther. So you would highlight those. What do you know about gas giants? Use what you know to make a hypothesis about what would happen if humans tried to land on Jupiter. So let's say Earth was getting blasted by meteors and we had to move to a new planet. What would happen, do you think, if humans tried to land on Jupiter? I want you to make a hypothesis. Either tell your thinking buddy, like a brother or sister or your dog, or write it down if you're by yourself. You can pause the video if you need to do that. So on this next slide, you're going to watch a video that's going to explain what happens if humans tried to land on Jupiter. As you watch, think about your hypothesis. Were you correct? Why or why not? So you got to have that idea of what would happen so that you can answer this question when you're done. So I encourage you, what's going to happen? Think about it. Here we go. Make sure my volume's up nice and loud.
The best way to explore a new world is to land on it. That's why humans have sent spacecraft to the moon, Venus, Mars, Saturn's moon Titan, and more. But there are a few places in the solar system we will never understand as well as we'd like. One of them is Jupiter. Jupiter is made of mostly hydrogen and helium gas, so trying to land on it would be like trying to land on a cloud here on Earth. There's no outer crust to break your fall on Jupiter, just an endless stretch of atmosphere. The big question then is, could you fall through one end of Jupiter and out the other? Turns out, you wouldn't even make it halfway. First things first, Jupiter's atmosphere has no oxygen, so make sure you bring plenty with you to breathe. The next problem is the scorching temperatures, so pack an air conditioner. Now, you're ready for a journey of epic proportions. For scale, here's how many Earths you could stack from Jupiter's center. As you enter the top of the atmosphere, you're traveling at 110,000 miles per hour under the pull of Jupiter's gravity. But brace yourself. You'll quickly hit the denser atmosphere below, which will hit you like a wall. It won't be enough to stop you, though. After about 3 minutes, you'll reach the cloud tops, 155 miles down. Here, you'll experience the full brunt of Jupiter's rotation. Jupiter is actually the fastest rotating planet in our solar system. One day lasts about 9.5 Earth hours. This creates powerful winds that can whip around the planet at more than 300 miles per hour. About 75 miles below the clouds, you reach the limit of human exploration. Galileo probe made it this far when it dove into Jupiter's atmosphere in 1995. It only lasted 58 minutes before losing contact and was eventually destroyed by the crushing pressure. Down here, the pressure is nearly 100 times what it is on Earth's surface. And you won't be able to see anything, so you'll have to rely on instruments to explore your surroundings. By 430 miles down, the pressure is 1,150 times higher. You might be able to survive down here if you were in a spacecraft built like the Trieste submarine, the deepest diving submarine on Earth. Any deeper, and the pressure and the temperature will be too great for the spacecraft to endure. However, let's say that you could find a way to descend even further. You will uncover some of Jupiter's grandest mysteries. But sadly, you'll have no way to tell anyone. Jupiter's deep atmosphere absorbs radio waves, so you'll be shut off from the outside world, unable to communicate. Once you've reached 2,500 miles down,
TikTok.
the temperature is 6,100 degrees Fahrenheit. That's hot enough to melt tungsten, the metal with the highest melting point in the universe.
6,100
At this
degrees.
point, you will have been falling for at least 12 hours, and you won't even be halfway through. At 13,000 miles down, you'll reach Jupiter's innermost layer. Here the pressure is 2 million times stronger than that of Earth's surface, and the temperature is hotter than the surface of the sun. These conditions are so extreme that
We're going to stop there. I think you get the idea. So was your hypothesis correct? What would happen if you tried to land on Jupiter? Do you think this would happen on all the other outer planets? So I encourage you to, on your piece of paper, write down what you learned, or you can do it here if you're doing it on Nearpod. One thing you should be writing about is we just keep on falling, right? There's no, if it's made out of gas, there's no hard surfaces or solids for our bodies to land on. So we're just going to keep on sinking farther and farther into the gas. So one thing you write, if humans tried to land on Jupiter, they would keep falling because there is no solid surface. What else might happen? Did you see in the video? Oh yeah, there's tons of pressure. So if you've ever gone swimming maybe and swam to the bottom of a pool, you might feel the water on top of you pushing on your body. We say that's more pressure. But on Jupiter, as you go farther and farther into the middle of the planet, there's going to be more and more stuff pushing on your body. That pressure's got enough force on it to push your body and squish it like a pancake. So your body would get crushed just because of how much stuff is pushing down on top of you, how much gas. So another problem would be all the pressure pushing on your body. And then the last part of this question, do you think this would happen on all the other planets? Well, let's think. Are they all made out of gas? Yeah. Are they all pretty large, meaning they're going to have a lot of stuff to push on your body? Yeah. So you might say, I think this would be a problem on all the outer planets. You could think of different reasons. The video gave you at least a few. You're welcome to watch the whole thing if you want even more ideas, but this is what I came up with. Alright, so the last thing is our exit ticket. Remember, the outer planets are massive spheres of gas that have no hard surface. Because they are so large, they have a huge gravitational pull, which causes many of them to have tons of moons or rings orbiting around them. What other things do you think you should remember about the outer planets? So we're going to take our exit ticket. You got to remember they're made out of gas. They're huge. They got lots of moons. What other things might be helpful for you to remember? Think about that for a second. All right, here we go. Remember, you can do it on Nearpod, or if you have a paper, just write the answer, and then you can send a picture to me or put it with your packet. In 3 or 4 sentences, explain how the outer planets are different than the inner planets of our solar system. So in 3 to 4 sentences, 1, 2, 3, 4, explain how the outer planets are different from the inner planets. Remember, complete sentences, use race, restate the question, answer the question, explain your thinking. After that is our quiz. Just write the correct answer. The outer planets are made mostly of rocks, gas, water. That should be an easy one. Why do outer planets have more moons and other satellites orbiting them than the inner planets do? So why do the outer planets have more moons and satellites orbiting them? They're smaller, so they have more gravity. They're larger, so they have more gravity. They are larger, so they have less gravity. They're smaller, so they have less gravity. Pick your answer, write the letter. Last question. This planet has majestic rings orbiting around it. Jupiter, Saturn, Uranus, or Neptune? Which one has the majestic rings? Pick your answer, write the letter on the paper. Once you're finished, you'll hit submit, and that's it. If you have any questions, please feel free to call me or text me, or even call or text Ms. Perkins or Hutchins. They'd be happy to do their best to answer the questions. If you ever need to go back and watch a video over again, you're welcome to do that before you take your exit ticket. I miss you guys. I hope you're all well. Keep putting in the hard work. I'm so proud of you. I know this is weird, and especially stinks because we're 5th graders and this is our last year at this school. But I know you're doing awesome work. I miss you. Talk to you later. Bye.